Hey guys, hi everybody. I'm going to talk about Open19 technology. I'm Sergiy Zhuk. I'm running the hardware engineering at LinkedIn. So basically, this is what it looks like. We essentially have an enclosures in a standard 19-inch cabinet. Those enclosures can be 12 RUs or 8 RUs. They accept up to 4 bricks, and we have different standards for what we call bricks. So essentially, our workhorse is the half-wide 1 RU server. It's on the left side. Then we have the other 3 form factors. We have double high half-width 2 RU, double wide brick, and we have the double high brick, which is 2 RU full. So the important part of it, they are self-sustained. They all have their own chassis, so EMI is not a problem. Because in some version initially, like with OCP, they weren't isolated, so you couldn't deploy them together with other tenants in the data center. So these are not; these are all EMI compliant. These are the cables that we use to connect the bricks to the power shelf and to the network switch. So essentially, it's 400 watts per server connection, and it's either 8 or 12 servers per cable based on the enclosure size. So what it means is that if you deploy, say, a wide brick, you can use 2 of those power connectors, so your total power per brick would go up to 800 watts. And if you use full 2U, that's 4x that. So you are not limited to just 1 power connector per brick. The data cables, those are universal connectors that we use, and it's up to 100 gig per server. But again, the server being half-width, 1U size. So if you have a wide brick, you can use 2 of those network connectors. You can get up to 200 gig per server. The power shelf, essentially, we don't have power supplies in the bricks themselves, so the power is in the power shelf. It can provide, in 1 RU, it can provide up to 9.2 kilowatts of power. So the conversion is done at the power shelf level, so you can still have AC power supplied to the cabinet, and the conversion is done by a power shelf. So the servers themselves get 12 volts DC. It's fully redundant, and actually in that design, the power shelf design, it has 2 controllers for BMC. We can work active-active, we can work as master-slave. So it's highly reliable. You can monitor the power per port. You can use e-fuses to shut them down, turn them on, and monitor the power data as well. Benefits of the technology. So as we said, actually you can deploy it in any 19-inch rack, which is really convenient for adoption, right? So traditionally with 21-inch OCP rack, you essentially have to deploy it from the get-go. So if you build a greenfield data center, or if you build your own data center in even a wholesale space, you essentially have to design it for that, right? But for companies that are like mid-size or smaller companies, it's usually not an option, right? So with this technology, you can actually deploy in parallel with deploying your current OEM SKUs. You can even deploy them in the same cabinet if you want, because it's just the enclosure that matters. So that way, it's easier for you to ramp and actually start deploying this tech in parallel with the existing tech. Integration, it's like 5-6 times faster at the rack level integration. And the reason why is no cabling. So you essentially have 2 harnesses on the back, 1 for power, 1 for network. There's no cables going down to the node. They all snap in. So you just push the blade in and it's in place. And you can definitely look at it in our booth, the full setup. So we already talked about redundancy for the power. Efficiency as well, because we have no power supplies and servers. It's much more efficient to convert AC to DC centrally. Cost as well, right? So you don't have a lot of integration cost. You don't really need to use system integrators to build the whole rack for you, because it's so easy to plug those modules in. And it gives you extra flexibility as well, because you don't actually have to pre-plan your deployment and say, okay, I'm going to put this many of this SKU and this many of this SKU. You can deploy them as you go, because the design is flexible. The dividers in the chassis are removable. So if you want to deploy different form factors, you can. Those are like live pictures from maybe like 2 months back. So you can see like on the left, those are Open19 enclosures with like PowerShell deployed. On the right are real servers deployed already. Also, if you heard about the Olympus project, we essentially incorporated Olympus as a part of the Open19 design as well. So we leveraged the Olympus project in the design of that specific SKU. So it's the same mainboard, everything the same as Olympus. We just fitted in into the Open19 form factor. So it gives you kind of an idea that if you already have an existing vendor or existing SKU, you can reuse the technology, just add an interface card to convert the network connectivity power on the back and be up and running. So future, we're going to have different cage form factors based on demand. So as I said, we have 8 RU and 12 RU. That was the most usable design for us, but we can modify it because it's essentially sheet metal. So you can create your own form factors. New server models. So we have a couple of standard bricks that we come up with. So those are standard application compute nodes. They support NVMe. So we have at least 2 NVMe per node. Those are U.2 form factor with toolless slots, so you can deploy SSDs on the fly as well. We have a storage node that is a full 1U, full width. There's 12 drive, removable trays. And we have the Olympus SKU that is essentially for high memory applications. So it has both NVMe support and a very large memory footprint. And another design that we have is very dense design. It's called Yellow Submarine. It's essentially a 4-socket system in half a U. So it's a half width 1U brick with 4 nodes on it. So with that form factor, you can deploy 300 plus of them per cabinet, which is really high density. And one of the new projects that we've been doing is the liquid cooling. So essentially, our ideology as Open19 is use blind make connectors for everything, so you don't have cabling issues. The liquid cooling that we implemented, the prototype you can see in our booth, also is using blind make connectivity. The whole idea is provide cooling down to the brick, not at the cabinet level, even half the cabinet level. So you can only cool the high performance SKUs, say you have a lot of GPUs in the system or high-end CPUs that consume a lot of power, need a lot of cooling. So you can deliver it down to the brick without compromising cooling for the rest of the cabinet. Definitely, and as you've heard from the keynote that Zaid did earlier in the morning, this technology has been contributed to the OCP. So hopefully that will help drive adoption. And part of the reason why we did it in the first place is to actually drive the adoption. Because with this technology, as I said, it's easier to deploy the OCP in parallel with your existing system without modifying your data center infrastructure. So we have about 5 minutes left. If you guys have any questions, I'd be glad to answer. If not, you're more than welcome to visit our booth and touch it. It's all there. It's completely implemented. Thank you for your attention. Yeah.